Hello, hello, and welcome to the 11-2 notes on areas of trapezoids and kites. And actually, we're going to throw in some rhombuses as well. Today's objectives are to calculate the area of trapezoids and kites, not triangles and parallelograms. That was yesterday. And we're going to use areas to calculate missing sides and angle measures. Okay, so if you recall from Chapter 8, a trapezoid is a quadrilateral that has two parallel sides, or one set of opposite sides that is parallel, and then the other two sides are called the legs. Those are the non-parallel sides. So today we're going to label these sides as base 1, because it does have two bases, and base 2. Now we also need the height of a parallel, or a trapezoid, and the way we measure that is from a vertex to the opposite side along a perpendicular. That is the height of it. Now that would be the same if I took the height right here, and I could even have the height on the outside. Those would all be the exact same length, and even from K down to this opposite side. So the area of a trapezoid is 1/2 times the height, and then you have to find the sum of the bases, so B1 plus B2. Alrighty, let's take a look at this first example. We want to find the area of the figure below, and it just so happens to be a trapezoid. How convenient. So the area, like I said above, is 1/2 the height, and then we're going to add the two bases, B1 plus B2. So I'm going to have 1/2. The height here is the leg because it is from a vertex to the opposite side along the perpendicular, so it's 1/2 of 4, and then inside the parentheses we're going to add the bases, so 6 plus 8. Half of 4 is 2. 6 plus 8 is 14. So this gives me my grand total, which is 28, and then my units are feet squared. So that was a simple plug and chug. We just plugged in all the information that we needed to find the area, and we got it. The second example, they tell us that trapezoid ABCD has base lengths of 17 and 31, and they give us the area. This time we have to find the height. So again, I'm going to write the equation. The area is 1/2 times the height, and then we add the two bases. So this time I'm still going to be plugging in, except I have the area instead of having the height. So I'm going to write 624 equals 1/2 the height, and then I'm going to add the two bases, which are 17 and 31. Working through this equation, I'm going to get 624 equals 1/2 h. 17 plus 31 is 48. Now I could get rid of this 1/2 right away by either just multiplying both sides by 2, or I could take half of 48, which I'm going to do it that way. So 624 equals 24 times the height, divide both sides by 24, and I get my height, which is 26, and my units are centimeters. I don't square it because height is not a squared measurement, it's just straight centimeters. Next up, we're going to have the area of a rhombus and a kite. Now, over here in this picture, we have a kite drawn, and if you remember, a kite and a rhombus, or any quadrilateral really, has two of these segments that connect opposite diagonals, and or opposite vertices. They're called diagonals. So we're going to call this D1, and then the one from O to N, or M, I'm going to call D2. The area of a rhombus and a kite is the same. You take half, and then you multiply the first diagonal times the second diagonal. So again, that's for a rhombus and a kite. It's 1/2 times D1 times D2. Let's quickly go through and review the diagonal properties of both a rhombus and a kite, because there are going to be problems where you're going to have to use trig, or you're going to have to split the angles, or you have to know certain things about the diagonals, whether they're perpendicular, whether they're not. So let's go through and talk about them. In a rhombus, the diagonals are perpendicular. And additionally, they bisect opposite angles. Because a rhombus is a parallelogram, the diagonals also bisect each other. Okay, a kite is not a parallelogram, so it's not going to have that last property that a rhombus does. The diagonals don't bisect each other, but they are also perpendicular. And there are two additional properties. So I'm going to actually draw a kite so that I could show you in the picture what happens. So here are my diagonals. Ugh, that's pretty bad. They're perpendicular. So again, in a kite, those two sides, two adjacent sides are congruent, and then two other adjacent sides are congruent. Opposite sides are not congruent, but there are two sets of congruent sides. They're just ones that are next to each other. So this diagonal gets bisected, one of them, and it's going to be this one. Additionally, angles get bisected. So this angle will get bisected, it becomes congruent, and then this angle gets bisected, it becomes congruent. So if I label this, let's say A, B, C, D, A and C are not congruent angles, but they get bisected. B and D are congruent angles. Those do equal each other. Okay, so let's write down those two properties. There is a diagonal that bisects one pair of opposite angles, and then one diagonal gets bisected. Meaning it gets split into two equal pieces. In example 3 here, they told me that kite LMNO, they gave me the length of LN is 14 feet, MO is 12 feet, and we're going to find the area. So the first thing I'm going to do is draw this kite. And it doesn't matter how you draw it, just draw it better than I just did. LMNO. Okay, they gave me the length of LN, so it's a diagonal is 14. And then they gave me the other diagonal, MO, and that length is 12 feet. So the two things that I need to find the area of a kite are its two diagonals, because the formula is 1/2 D1 times D2. So I'm going to plug these values in. I get 1/2 of 14 and then times 12. So 1/2 times 14 times 12. Now a big mistake that kids do make a lot of times here is they think, oh, I have to distribute here. Distribution only works over addition and subtraction. There is no addition or subtraction here, so it's just like if you were multiplying 2 times 3 times 4. It doesn't matter which order you multiply those three numbers, but you do 2 at a time. So it'd be 6 times 4, giving you 24. If I did it in a different order, say I did 3 times 4 first, that's 12. 2 times 12, that also gives me 24. I wouldn't do 2 times 3 and get 6, and then 2 times 4 and get 8. 6 times 8 is 48. That's too much. So we're going to do the same thing here. You're going to take half of either 14 or half of 12. I'm going to do half of 14 is 7, and then multiply by 12, giving me my answer, which is the area is 84 feet squared. Alright, example 4 becomes a little bit more difficult because they're not giving me actual values for the diagonals, and they're giving me the area. So it says one diagonal of a kite is 3 times as long as the other diagonal. If the area of the kite is 216 square inches, what are the lengths of the diagonals? Okay, so let's call diagonal 1 x. And then if the first diagonal is x, because I don't know it, so that's why I'm calling it x, it does tell me that the second one, or one of the diagonals, is 3 times the other. So this one has to be 3 times whatever that first diagonal is, which I called x. So let's plug into our formula. Area equals 1/2 times d1 times d2. I'm going to get 1/2 x times 3x. And I know the area, so I'm going to plug in 216. Now, working through this, I'm going to have 1/2 times 3x squared. I could take half of 3 and have 1.5, but at this point, this is where I'd like to get rid of the fraction because 2 doesn't go evenly into 3. So at this point, because of that, what I would do is I'd multiply both sides by 2 to get rid of that 1/2. You don't have to. You can write that as 1.5x squared. But then remember, if you're doing this without a calculator, if you have to divide by 1.5, that becomes a lot more difficult than dividing by 3. So 2 times 216 gives me 432 equals 3x squared. I'm going to divide both sides by 3, and I get x squared is equal to 144 Square root both sides to get rid of the x squared, and we're going to get x equals plus or minus 12. Because x represents a length, we don't want the negative value, so it's 12. Okay, so going back to what the question asked me, it said, what are the lengths of the diagonals? Well, if x is 12, that's diagonal 1. Right here we called it x, so it's 12, and my units are inches. And then the second diagonal is 3 times x, so 3 times 12 gives me 36 inches. Just like yesterday, I could double check my answer by seeing, is the area of 1/2 times 12 times 36, does that give me an area of 216? It does, so then I know that I found the right x value, and therefore my two diagonals are 12 and 36. Okay, example number 5 over here. They told me that the area of rhombus FIGAG is 64 centimeters squared. If IH is 2 centimeters, find FH. So let's label what we have here. IH is 2. And they gave me the area. Those are the only two things they gave me. So remember that the area of a rhombus is the same as the area of a kite. It's 1/2 times the diagonal 1 times the length of diagonal 2. It's for a problem like this where those properties of diagonals of rhombuses and kites becomes really important, because I know now, because this is a rhombus, the diagonals bisect each other. So this piece and this piece are congruent. IH to HG and FH to HJ are congruent. So therefore I know that HG is also 2. So now I have enough information. I'm only missing diagonal 2. I could plug in all the numbers that they gave me, the values. So the area is 64 equals 1/2. It doesn't matter which one I call diagonal 1, but I'll call this one diagonal 1. So if it's 2 and 2, its total length is 4, and then I have D2. Because 1/2 times 4 is a nice number, I'll just multiply those two. So I get 64 equals 2 times the length of the second diagonal. Divide both sides by 2, I get 32 equals D2. Again, just to make sure, because I'm paranoid, I want to make sure that it's right, I'm going to do 1/2 times 4 times 32 and see what I get. I should get 64 if I did this correctly. Half of 4 is 2 times 32 does give me that area that they gave me, which was 64. So diagonal 2 is 32, and then I forgot my units. Don't do that. Always remember them. Okay, last example on this page, they gave me a figure and they want me to calculate the area of it. Hopefully you do recognize this figure as a trapezoid. From the first page, the area is 1/2 times the height times the sum of the two bases. So if I have to calculate the area of this figure, I need its height, which I do, it's 20. I need both of the bases. I have this base, but notice that I'm missing this bottom base. So what I do is I drop the altitude right there. Wow, that was pretty straight. I know if this is 21 up here, that's going to be 21 down there. So I know at least a piece of this base. What I'm missing is this little chunk there. So if you think about this little right triangle, I'm missing one of its legs. So as you should think up till now, and if you're missing sides of a right triangle, we're either going to use Pythagorean theorem or we're going to use trig. Now I could tell from this picture we're not going to use trig because I'm missing a key piece of information, which is an angle. I'm not just going to say, oh, you know what, that looks like it's about 60 degrees, so we'll call it that. You can't do that. Instead, what you have to do is carry this 20 over. This is still the same height. So what I'm looking at here is a right triangle whose hypotenuse is 29, one of the legs is 20, and then I'm looking for that missing bottom piece. I'm going to call it x. So I'm going to do Pythagorean theorem. So 20 squared plus x squared, the sum of the two legs squared, equals the hypotenuse squared. So 400 plus x squared equals 841. So x squared is going to equal 441. Okay, at this point, to get x, I'm going to take the square root of both sides. And as always, when you take the square root of both sides of an equation, you're going to get both plus and minus, and the answer here is 21. Because x represents a length, we only want the positive value that it has, which is 21. Okay, so if that's 21, that I just found, and this is 21. The entire length of this base here, I add the two numbers, it's going to be 42. So by doing that, I have now found all the information that I need to find the area of this trapezoid. So it's 1/2. The height of it is 20, and then I'm going to add the two bases. Top base is 21 plus the bottom base is 42. Half of 20 is 10. Goes in nicely, so I just add those two. And then 21 plus 42 is 63. So the area of this trapezoid is 630. They didn't give me any units, so I'm just going to write units squared. All right, so let's see. Did we accomplish the objectives? We wanted to be able to calculate the area of trapezoids and kites and rhombuses, and we wanted to use the areas to find missing side and angle measures. So this problem over here, you're making this flower decoration for your house in the shape of a kite. I want you to do this on your own. Example 7, I'm going to do with you because it's a doozy. All right, so we have the area of kite math is 17 square feet, and they gave me some lengths, MT and AH. So the first thing I do is I'm going to draw this picture because that's just how I do it. Okay, so MATH, that spells math. All right, drawing the diagonals. Again, it doesn't look so great. I'm always really bad at kites. But they told me that MT, this diagonal here, is 2x plus 5. And then AH, the other diagonal, is x minus 4. And again, it doesn't matter at all how you would draw it. If I had this flipped around somehow, it's still going to give me the correct answer. So the area of a kite is 1/2 d1 times d2. Let's fill in what we know. They told me that the area is 17 equals 1/2. Then I'm going to plug in my two diagonals. So x minus 4, 2x plus 5. This now becomes a very similar problem to yesterday's triangle problems, where I'm going to get rid of this 1/2 by multiplying both sides by 2. I get 34 equals, and then I have my two binomials that I'm going to multiply. Okay, let's go ahead and FOIL or distribute, whatever you call it, the right side of this equation. So I'm going to get 34, stays there, and I get 2x squared plus 5x minus 8x minus 20. Let's combine like terms on the right side. So it's going to be 2x squared minus 3x minus 20. Now I can't factor or even do quadratic formula yet because this equation does not equal 0. Before you solve a quadratic, you have to get it equal to 0. So I'm going to subtract 34 from both sides. I get 0 equals 2x squared minus 3x minus 54. All right, now we are ready to factor. All right, so now that we have this quadratic equal to 0, we are ready to factor. So we always take the product of a, which is the number in front of x squared, times c, which is your constant. So 2 times negative 54 gives me negative 108, and I'm looking for numbers that add up to b, the middle number, so negative 3. If you don't know the factors of negative 1 and 8 off the top of your head, that's totally fine. Let's just start listing them. Now, I'm going to list them as both positive numbers, but keeping in mind the entire time that one of them has to be negative. And how do I know that? Because they have to multiply to be a negative number. But in any case, 1 times 108, no combination. If I make one negative or 108 negative, that's not going to give me negative 3. So let's keep going. 2 goes into 108 54 times, not going to work. 3 goes into 108 36 times, that's not going to work. 4 goes into 108 27 times, no sum of those is going to equal negative 3. 5 doesn't go in. 6 does go into 108, and it goes in 18 times. That does not work. 7 doesn't go into 108. 8 doesn't go into 108. 9 goes into 108 12 times. So hopefully you see that if I make one of these negative, I will get a sum of negative 3. So which one do I make negative? Well, because they have to add up to negative 3, it's going to be negative 12. All right, that is as far as I'm taking you in this problem. What I expect to see tomorrow is for you to take this middle term. You're going to split it. Remember, we found those two factors that we need, so you split this middle term, write the negative 1 first, if you have one that's positive, one's negative, it just makes it a little bit easier, and solve. All right, for tomorrow, I also expect you to do example 1 right here, this trapezoid problem. And then example 2, we're going to do in class together because there's some information missing. So we're going to have to give an angle measurement to find that. All right, thank you for watching. If you have any questions, please make sure you ask your teacher in class tomorrow. Thanks and have a good day.